Thank you for joining us for our second video on Tolomatic's online sizing software. Today we'll be taking a look at the Motion Profiler tab and the details we enter on this page. So at this point you would have completed the application details page where you define the initial application requirements. On this page we're defining how the actuator will move, the speeds, velocities that it'll need, as well as the loads and forces for the application. The first section we have here is the Profiles and Segments tab. This is where we define the motion profile. Clicking on Add New Velocity Profile allows you to start defining that motion profile. Profile name is a text entry. Here you can help define what the motion profile is and what will be occurring during this move. So for example, if we're thinking about a press application, we can add actuator extend move, and then define this profile as the actuator would move to extend to the point of work. So in this case, we'll define a move distance. This is how far the actuator will extend. You'll notice below there's motion direction. Forward is away from the actuator, extending the actuator rod, or reverse is retracting towards the actuator, towards that motor assembly. So for this move, we'll define a move of 3 inches, extending in 1 second. And here we enter the time input in seconds. You can also do a velocity input, what the maximum velocity of the move should be, and then the sizing software will calculate the time it takes for that move. In this case, we'll input a time, and then the sizing software will define the maximum velocity. You'll notice there's 2 motion profile types you can select from, a trapezoidal move or a triangular move. These will impact the max velocity of the move as well as the various acceleration rates. And again, the sizing software calculates those acceleration rates to meet those move distance and time inputs that you apply here. If you've defined loads for the application, you can select the loads that will be applied to this profile. So at this point, we'll add this velocity profile. You'll see then that image on your screen, and we can proceed with adding the second part of our velocity profile here, which will be that press move. So again, we'll define that press move in the profile name. That helps us reference each of these move segments later on when we output those into a sizing PDF. This will be a 1/2 inch press move, again away from the actuator, occurring over a 1/2 second. We'll add this velocity profile here, and then at a later time we'll define that press force. So this is, we've completed the extend portion of the actuator move. Now we'll define the retract. So reverse is selected. Max allowed, that'll define here how many inches are allowed to retract. So this takes into account the total stroke length of the actuator that we defined on the previous application detail page, and then the distance that we've extended through the first 2 moves. So we'll retract 3.5 inches to the home position. We'll do this in 2 seconds. And with the triangular move. It's important when taking into account your motion profile to factor in any dwells in the cycle. So the sizing software will do a thermal calculation for the roller screw or ball screw assembly and factor in these dwells. So we'll add in a dwell here between cycles. This could be for time to load parts or for process delays or considerations. In this case, we'll add a 2-second dwell time, defining that dwell for part loading, and add that to the motion profile. So here we see a complete motion profile defined with dwells, allowing the sizing software to take that into account for the thermal considerations. You'll notice here we'll see velocity 3. This indicates that we haven't defined that velocity profile, or haven't defined a name for that velocity profile, so we'll define that here to retract move. And again, that'll help us later on when we're applying loads or forces to each of these segments. If you wish to edit your motion profile or add a segment or dwell into your already defined profile, you can click on one of the moves that you would like to add the segment or dwell after, and then click Add New Velocity Profile or Dwell. This will add that move or dwell after your selected row here. You'll notice when we're defining these moves, you can edit what you've already defined by clicking on Edit, and this will show you your parameters you previously entered and allow you to adjust those. Another feature we have here is advanced motion profiles. This allows for some more complex moves. This is a feature that's covered in our Tolo U training class held at Tolomatic and can also be discussed with your application engineering team. Next, we'll define what loads and forces are present during the application and what moves or dwells these are present during. First, we'll define the load name. In this case, it'll be a tooling mass for our sample application here, and we'll define that as a 5-pound tooling mass. Percent supported by the actuator refers to what percent of the load the actuator will need to move or is supported on the actuator carriage assembly in the case of a rodless actuator. So in most cases, we'll leave this to be 100%. Here we have the moment prevention selection. This refers to if the actuator load is causing any side load to the actuator or if there's a guidance system built into the application that'll prevent side loading or deflection to the actuator rod. If such a guidance system is present, select guides to prevent deflection. Otherwise, define what the center of gravity of that load is, and that the sizing software will calculate any side loading or moments applied to the actuator rod, in the case of a rod actuator assembly or the carrier assembly. Below, you can define which sections of the profile, which moves or which dwells this load is present for. So here we'll define that for all loads. As we're saying, the actuator is going to be supporting that tooling mass through the entire profile. Next, we have the forces box here. Clicking to add a force. This will be the press force that's present during this application. We'll define that to be a 500-pound force. There will be guides to prevent deflection as the system is aligned and there's no offset load. If you're using a rodless carrier assembly and the force is offset from that carrier, you can define the center of the applied force using these boxes here. And again, we can select which profile sections this force will apply to. So in this case, it's helpful to name each of the segments. You can see press move here. We'll select that and apply the force to this segment. After entering a force effect, you've completed all the steps necessary to define the motion profile for your application. At that point, you can click Continue to Next Step, and that'll bring you to the product selector page. Thanks for watching our video on sizing Tolomatic actuators. We've covered the Motion Profiler tab. In future videos, we'll be looking at the Product Selector tab and walking you through the rest of the sizing process to generate your project summary and select a Tolomatic actuator solution. If you have any additional questions on the Tolomatic sizing process, please feel free to reach out to your Tolomatic application engineering team at the phone number and email shown on the screen.